This is Geometry, Chapter 10, Section 3, in which we will study the relationship between arcs and chords. If you remember back in 10.1, we talked about a chord being a segment that goes from one part of the circle to the other. The endpoints are on the circle, something like MN here, or PQ. Those are chords. Our first theorem here, Theorem 10.2, says that if we have the same circle, or to cover our bases, congruent circles would also work, two minor arcs, so arc MN and arc PQ, are congruent if and only if their chords are congruent. So arc MN is going to be equal to arc PQ if segment MN is equal to segment PQ, and vice versa. Okay. If the segments are equal, then the arcs. If the arcs are equal, then the segments. Okay. Notice here how important it is to make sure you can distinguish between the two ideas, because the symbols have to match up right. So let's tangle with this idea. If we're given that arc RS is equal to arc TV, our job is to find the length of segment RS. And I can tell that they want the segment because there's no symbol there. And remember, RS without a symbol means length of segment. Well, if these two arcs are congruent, that means the two segments are congruent. And the two chords are equal. Well, now we bring the 2x over, bring the 9 over, do a little dividing. We find out that x equals 4. They want RS, so I'm going to plug the 4 back in. 5 times 4 is 20, minus 9 gives me a length of 11. Okay. Now, we've used this next idea, several times too. We've talked about dividing a segment into two equal parts. We've talked about dividing an angle into two equal parts. Now we're going to be dividing an arc into two equal parts. So we're talking about bisecting, in this case, the arc. Okay. We can bisect a segment. We can bisect an angle. We can also bisect an arc, cut it into two parts, two equal parts. And there are two theorems here that really go hand in hand. If a diameter is perpendicular to the chord, so AB here, the diameter, is perpendicular to XY, the chord, then it's going to bisect the chord and also bisect the arc. So this segment will be equal to this one, and arc XB will be congruent to arc YB. And the opposite is true. If this thing is the perpendicular bisector of a chord, then that makes it a diameter. Okay. If you see a diameter, or for that matter a radius, perpendicular to a chord, then it's going to bisect the chord. If you see a radius bisecting a chord, that's going to tip you off that it's perpendicular. That's what these two theorems together tell you. So let's make use of this. They've told me that arc PQR is 114. Now I know we have 3 letters here, so that usually would tip you off to being over 180. But they wanted to emphasize which way to go. Go through Q. If this is 114, our job is to find arc PQ. Since this is perpendicular to this, that means it's a bisector. So arc PQ is half of the total. Arc PQ is 57. Our other job here is to find PR, find the length across from P to R this way. Well, if this part is 6 and that's perpendicular, that's also a bisector. So if that's 6, then PT is 6. So PR would be 2 times 6, or you could say 6 plus 6. Either way, you get 12. Okay. Let's expand on this idea. Our mission, our job, is to find the length of VT. Now, since I know I have a radius here, or a perpendicular, that's going to tip me off that I could get a right triangle. So I'm going to draw in another line, another radius here. Now the question is, how long is this line? Well, the radius from R out to U is 11. So then the radius from R to T would also have to be 11. Remember, inside the circle, all the radii are congruent. I am just going to fix that real quick. Might want to make that adjustment on your note sheet. I had my 5 and my 6 in the wrong spots. It's easier to fix that than to go back and fix all this. So do a little cleanup work. Take the square root, and that tells me what ST is. I want to know what VT is. Well, that'll be double ST. Okay. Hopefully by now you recognize this formula is something you know and love, the Pythagorean theorem. Okay. When you have that right angle, that's a tip-off that we're working with a right triangle. We just sometimes have to add in that extra line to make the right triangle. But we can do that. Okay. One last idea here. Chords will be congruent if and only if they are equidistant from the center. Okay. What they're telling you here is if you have two chords that are the same distance out from the center, then they're equal to each other. And also, if you have two chords equal to each other, that means they're the same distance out from the center. If they're equally distant from the middle, then they're equal to each other. And if they're equal to each other, then that means they're equally distant. Hopefully, if you had questions along the way, as we worked through arcs and chords, you wrote those down, I hope. You can bring them in, and we will see you in class.